Bismillahirrahmanirrahim. Dear students, I hope you are all very well. And today, this is our second lecture of physics. Now we will start our new chapter, that is the nuclear physics. As this name shows that this is based on the nuclear. Nuclear arises from the word nucleus, and a nucleus is a part of an atom. So in this chapter we will discuss the properties and structure of atomic nucleus. So we start by describing the phenomena of radioactivity, nuclear transmutation and half-life. And also we will discuss the phenomena, all the phenomena which are based on atom and atomic nucleus, like fission and fusion reactions. Or we will discuss the atomic nucleus. So we have to know that what is nucleus and how the changes occur after bombarded any radiations on the nucleus. So nucleus is a part of an atom. So whenever we talk about the atom or atomic nucleus, so this atom shows that this is the smallest indivisible particle. No doubt it is now further subdivided, but before this the atom was considered as the smallest particle. Now we will start our first topic, that is atom and atomic nucleus. So we have to know that how the atom is generated. So scientists considered and tried to discuss that all the matter should be divided into the smallest particle. And they considered after some experiments and predict that the matter is divided into the smallest particle, that is known as the atom. But after research of the scientist, it is concluded that atom is not the indivisible particle. It is further subdivided into the different particles that are known as the subatomic particles. So Democritus was the first scientist who gave the idea of the atoms. And atom is the ancient Greek word which means indivisible. Indivisible means not divided further. And then the Ernest Rutherford, another scientist in 1911, he discussed the structure of an atom and told us that the atom has two parts or two portions, the central portion and the surrounding portion. The central portion is known as the nucleus, in which the protons and the neutrons are present, while the electrons are revolving around the positively charged core or nucleus. So we have to remember it that proton and neutrons are present in the nucleus. So protons are the positively charged particles, while the neutrons means neutral, so there is no charge on neutron, therefore the nucleus show the positively charged, whereas the electrons, which are the negatively charged particles, revolve around the nucleus. These number of protons and the number of electrons have the different or opposite sign but have the same number, therefore the atom is electrically neutral. And proton is 1836 times heavier than the electrons, therefore the protons will kept in nucleus. So here in this figure you can see that the protons and neutrons are present within the nucleus, while the electrons are revolving around the nucleus. So keep it in mind that the electrons were discovered by J.J. Thomson, while the neutrons were discovered by Chadwick and protons were discovered by the scientist Goldstein. The nucleus lies at the center of the atom and occupying only 10 power minus 15 of its volume, since the electrical force comes from both the electron and the nucleus, as shown in figure page number 235. The nucleus is about 10,000 times smaller than atom, and the size difference is like a ping pong ball, that is a ball which is of very small size in the center of 2 kilometers circle, as shown in figure. Here you can see the volume occupied by the negatively charged electrons. So scientists concluded that all nuclei are composed of two types of the particles, that are protons and neutrons, and these protons and neutrons are collectively known as nucleons. So how many protons and neutrons are present in any atom? So we will discuss the terms which we'll use in the study of the atom. The first term is the atomic number, which is represented by capital Z and which is equal to the number of protons in the nucleus. We can say that the number of electrons revolving around the nucleus. The second term is the mass number or atomic mass number, which is represented by capital A, and it is equal to the number of protons plus number of neutrons, or we can collectively say that the number of nucleons. Therefore, mass number is also known as the nucleon. The third term is the neutron number, which is represented by capital N and which is equal to the number of neutrons in the nucleus. If we want to find out the number, how many number of neutrons are present in an atom or in a nucleus, then we will subtract the atomic number from the mass number, means A minus Z. Then we can easily find out how many number of neutrons are present in concerned atom. Now, in representing the nuclei, it is convenient to have a system of symbols to show how many protons and neutrons are present. So this is the way to express the elements with its atomic number and the mass number respectively. Here X shows the chemical symbol for any element, while A shows the mass number that we will get by the addition of number of protons and number of neutrons, or we can simply say the atomic number plus number of neutrons, where Z shows the atomic number, which is equal to the number of protons, and capital N shows the number of neutrons, but there is no need to write it in this symbol. Now we will take an example of iron. The symbol of iron is Fe and the atomic number is 26 while the mass number is 56. Therefore, it contains the 26 protons, 26 electrons, and when we subtract 26 from 56, then we will get 30 neutrons. So we can write it like, instead of X, we can write Fe, symbol A replaced by 56 and symbol Z replaced by 26. The subscript Z is thus sometimes dropped. For example, when we take an example of nitrogen, so the atomic number of nitrogen is 7 and atomic mass of nitrogen is 15. So we already know that Z is 7 for nitrogen and we simply write it as nitrogen 15, or may write as nitrogen 15. The nuclei of all the atoms of a particular element contain the same number of protons and consequently electrons in a neutral atom, but often contain different number of neutrons. So when the nuclei of atoms which have the same number of neutrons and protons, then they are termed as nuclides. For example, in this example of carbon, whose atomic number is 6 and atomic mass is 12. So when we want to find out the number of neutrons, then we will subtract 6 from 12, then we get the number of neutrons is also equal to 6. In this example, there are 6 number of protons and 6 number of neutrons. So therefore, the nucleus of carbon is also known as nuclides because of the same number of protons and neutrons. So within the nucleus there are positive charges that also shows the atomic number. To keep these charges from flying apart, the nuclear force must supply an attraction that overcomes their electrical repulsion, due to which the protons must be present within the nucleus due to the attractive force within the nucleus. So this is all about the atom and the atomic nucleus. I hope you understand each and everything very clearly. Till the new topic, stay home, stay blessed. Allah Hafiz.